In this video, I'll show you how to build a fully automated deployment system using GitHub Actions, AWS EC2, Docker and Nginx. We'll set up everything to spin up new apps just in one click. Let's jump right in. Freelancers often manage multiple projects simultaneously, and it's awkward that some of us still set up our environments manually and uploading files via SSH or even FTP. Our goal is to create a simple, cost-effective and flexible solution that automates initialization and deployment in one click. This system will save you hours of repetitive work. Each project lives on its own GitHub repo containing Dockerfile and GitHub Actions workflow. When you push code, GitHub Actions automatically builds a Docker image and pushes it to a registry and triggers a script on our EC2 server. For new app initialization, the system detects new configurations in the workflow and automatically sets up the directory, Nginx proxy rules and SSL certificates. The EC2 server pulls the latest Docker image from registry, runs it in a container and ensures Nginx routes traffic correctly using the subdomain specified on the workflow. First, we will create an AWS EC2 instance. This server will handle all our apps, routes traffic through Nginx and manages our Docker containers. Here's how you create your EC2 instance in just few simple steps. So you have to be logged into your AWS management console, then go to EC2 dashboard and click Launch Instance. Choose Ubuntu and 2404 LTS. I recommend Ubuntu for stability and easy of use. Why Ubuntu? It's lightweight, secure, and has excellent compatibility with Docker and Nginx. Next, select instance type. For testing small projects, the T-micro instance is more than enough and qualifies for AWS free tier. If you are planning to host multiple production instances or handle higher traffic, you can always upgrade your instance type later, but for now let's keep things simple and use T2 micro. Next, we create a new key pair and download it. This will be used to SSH into your EC2 instance. Make sure to keep this file safe. You'll need it to connect to your server. If you lose it, you won't be able to access to your instance. Next, let's set up security group. Make sure you allow SSH traffic and HTTPS and HTTP. These are the essential ports you'll need to access to your server, to route traffic through Nginx and secure your application with HTTPS. And finally, press the launch instance. Once instance is running, connect via SSH using command SSH-e, then the path to the key we've just downloaded. Next, let's use Ubuntu as username, because it's default username you have on your EC2 instance after creating. Next, we have to take the public IP address. Yep, and here we are on our just created Ubuntu server. And that's it, you have your EC2 instance up and running. From here we'll move to configuring Nginx as a reserve proxy to handle multiple applications. Let's go! So we'll use Nginx as a reserve proxy. Install it directly on the host with sudo apt-get update and then sudo apt-get install -y Nginx. Make sure ports 80 and 443 are open in your firewall, for example with UFW. Next, we'll create a repository at Amazon ECR to store our Docker containers. This is where GitHub Actions will push after building the container. So go to ECR service in your AWS console. Next, click Create a repository, name it Hello Go, or any name you prefer, and press Create. Next, we configure AWS credential for GitHub. Open IAM dashboard, go to Users, create new user, name it, in my case it will be Duplux GitHub deploy. Go next, and here open attach policies directly. Find Amazon EC2 Container Registry Full Access Policy and add it. Also, to update DNS records in Route 53, we have to add Amazon Route 53 Full Access Policy. Go next and hit the Create User button. If you want more fine-grained control, create a custom policy. Let's set up our simple project. We'll create a Hello World Go server, but honestly, the language doesn't matter. You can use Node, Java, Python, or even front-end build will work at the same way. On GitHub, click New Repository, name it something like Deployment Template, initialize it. Next, add a main.go file. This is our Go server entry point. It starts an HTTP server on 8080 and returns a greeting. And also add a Dockerfile. This defines how to build and run our app in a container. For other languages, simply adjust the Dockerfile steps as needed. And finally, push our code to created repository. Next, in our repo, put deploy YAML file in GitHub Workflows directory. Here is the complete workflow that shows how to build, push and deploy our app to EC2 instance in just one click. Here we named the workflow and specifies it to run on any push to the master branch. Here we define that the job is running on Ubuntu virtual machine. Here we set global environment variables as well, like app name, in our case it's Hello Go, and image tag latest, so we can reference them easily. Next, we fetch the repository source code into the workflow runner. It's required for building the Docker image from local code. Then we set up AWS environment variables like AWS key ID from GitHub secrets for allowing AWS CLI commands to run ECR, Route 53, etc. with the correct permission. Next, we check if the application with provided name exists in ECR. If not, we create it. That excludes the need to manually set up new repositories. Next, we retrieve temporary login credentials from AWS for Docker. It's required to push or pull images from your ECR repo. Next, we build a Docker image from our code, tags it with Hello Go, in our case latest, and then push it to ECR. Then we update DNS records in Route 53. We observed a record here for hellogo.duplux.com, pointing to our EC2 API. This automates DNS changes so your domain routes directly to the EC2 instance. Then we install SSH key. This is required to log in to the EC2 server and run commands. And lastly, we deploy application on EC2. We pull the newly built image from ECR, stops any old containers, starts a new one, sets up Nginx as a reverse proxy, and optionally requests an SSL certificate. This is how we ensure the latest version of your application is running on EC2 under a secure domain. And of course, I'll share a link to the repo that contains the complete workflow file in the description below. Now we clarify where each secret comes from and how to obtain it. Storing these values as GitHub secrets, ensuring that sensitive information wouldn't be exposed in the code or in the logs. AWS Account ID is a unique ID of your AWS account. To find it, you have to log into the AWS Management Console, click on your account name top right corner, copy the 12-digit number and store it in GitHub Secrets as AWS Account ID. Access Key ID. It's a key ID generated for an IAM user with programmatic access we've created before. So to find it in the AWS Management Console, open IAM, then select our user. Under the Security Credentials tab, create a new access key. AWS shows access key and secret access key only once, so be sure you saved it in some safe place. Copy this access key ID and add it to GitHub Secrets as AWS access key ID. Also copy AWS secret access key and store it to GitHub Secrets as AWS secret access key. AWS default region is the default AWS region to run your AWS CLI commands. You can find it easy on the URI at the Management Console. EC2 host is a public IP address or the public DNS hostname of your EC2 instance. So go to EC2 in the AWS console, under Instances select the instance you want to deploy to, and in the description tab note the public IPv address or public IPv for DNS. Copy that value and add it to GitHub Secrets as EC2 host. EC2 SSH key. It's the private key used to SSH into your EC2 instance. When we created the EC2 instance, AWS promoted us to download a key. So we have to locate this file on our machine, copy everything including beginner RCA and end RCA lines, pass into GitHub Secret as EC2 SSH key, and that's it. The important thing is that never commit or expose this file. This must remain secret. Next one is known hosts. It contains one or more SSH host keys or fingerprints for your EC2 server. It's used for strict host key checking. So we can put SSH key scan -h with the public IP address of our EC2 instance. Then we copy the output directly into GitHub Secrets. This ensures SSH refuses to connect if the server's key changed unexpectedly. And the last one is certbot email. It's used by certbot or Let's Encrypt to register an SSL certificate. Use any valid email address that you control, as Let's Encrypt will send expiration notice there. Add it to GitHub Secrets as certbot email. Now is the funnest part, testing. Let's push the changes into the master branch and see how GitHub Actions will spin up our updates. But first, edit main.go to change the greeting. Then commit and push to master. Now we can watch the GitHub Actions run. After it finishes, open our hellogo.looks.com and check it what we have here. And it's work. If something goes wrong, here are common places to check. So the first one is GitHub Action Logs. Make sure the build push steps succeeded. Next one is EC2 Logs. SSH into your EC2 instance and run docker ps -a to see if the container is running. Next one, Nginx config. Check Nginx -t and your server blocks in etc Nginx sites available. And firewall security groups. Check that ports 80 and 443 are open. Let's see how it's easy now to create another application using our automation workflow. Imagine that you need some new microservice or create a different project. Here's what you need to do. Create a new repo, set up all secret variables as we did before, Then add your project files. In the GitHub workflows, paste the same deployment workflow we've used here. Update app name variable to match a new project and update the port, for example with 8081, to avoid any conflicts. Then push and watch. GitHub Actions will automatically build the Docker image, push it to ECR, create or update a DNS record, and deploy it to your EC2 instance behind Nginx. Once workflow is completed, open your subdomain and you will see your freshly deployed application without any manual SSH connections and file copying. This is the power of automated pipelines. You can create as many projects as you want, and each of them will have its own Docker container, Nginx configuration, and SSL certificate. It's a game changer for freelancers managing multiple projects. If you found this helpful, like, subscribe, and write in comments if you want some more advanced tutorials. See you next time. Stay in tech.